We in this department have been working on what's called biogasification, that is producing gas fuels from solid biomass feedstocks. It could be biomass feedstocks, or it could be municipal urban waste, yard waste, organic waste, food waste, all sort of residues. So the process involves using microbes, so bacteria, to convert the solid, particularly the solid organic waste, to methane as a fuel. So the biogas is a fuel that's produced. It's a mixture of methane and carbon dioxide. It's about 70% methane. And some of you will be aware of this process as anaerobic digestion. Typically, anaerobic digestion is being used in sewage treatment plants, so to convert sewage sludge to biogas. It's also used for manure digestion, that is from livestock waste. But you can also apply the process for other feedstocks, like high solids feedstocks, like energy crops, or, as I said, municipal waste, or any other organic matter. Okay, so we have been working on this area for the last 10 to 20 years, and have developed several designs. Some of it has gone commercial, some of it are being commercialized for different feedstocks. So I'll give you a run through a few examples of that, what we've done in the past. We had it in Walt Disney World down in Orlando, the Epcot Center. This particular project ran for about 5 to 6 years. The purpose of this project was to take the wastewater that is generated in the Walt Disney World Resort and to treat the wastewater using the water hyacinth. Water hyacinth is an aquatic plant. So water hyacinth takes up the nutrients and treats the wastewater. And then the next step was to convert the water hyacinth to energy, to biogas fuel. So the water hyacinth was harvested and put into a digester. So this is a digester. It's where you convert the water hyacinth to biogas as a fuel. So this particular project was carried out for about 5 or 6 years, and this is like a demonstration project. So what we demonstrated there was treatment of wastewater or sewage, plus production of energy from the treated aquatic plant. This is a project, this is for basically urban waste. So you can treat food waste, vegetable waste, fruit waste, any kind of organic matter. And the process is called CBAC. It stands for Sequential Batch Anaerobic Composting. And basically the biogas production process is done in these containers. So each container can handle about 30 to 50 tons of waste. So you load the container using front-end loaders, and then you seal the container, and then start inoculate the waste mixture, and it starts producing biogas. So you run the process for about 2 weeks, you recover all the fuel from it, open the container, empty the residue, and refill it with fresh waste, and the whole process is carried out. This particular technology is being commercialized by a company called Sigarca, and they have a couple of these facilities in Florida. One of them is in Ocala, where they're treating a mixture of horse waste. There's a huge horse farms down in Ocala, which is kind of south of here. And there's a lot of horse manure that's produced. And this particular system treats the horse manure along with the food and vegetable waste that's generated in some packing houses near the place. So that's been commercialized. Now this is a kind of a modification of the same CBAC process, but this is a facility that we built for NASA. Now NASA was interested in this particular technology, where they were looking at space missions. So when astronauts were going to stay in Moon on Mars, they had a program, the Mars program, as well as the Luna program. The astronauts would spend long times there, probably about a year. And the idea behind was to use this technology to convert their waste, which could be just the food waste. And also in the case of the Mars program, they were also going to grow plants there, crops for food and for oxygen. So we take the biomass, produce methane from it, And this is a prototype that we built for NASA. So basically, this is a system that will take in waste from 6 astronauts for a period of year, convert them to methane, and they were going to use the methane as a fuel to to come back as propulsion. So that's a prototype for NASA. And this is the most recent system that we designed, and it's a system to deal with this kind of a waste stream. This is from a sugar beet processing plant up in the area of Minnesota and North Dakota. They grow sugar beets, and sugar beets are grown for sugar. And the process of making sugar from sugar beets generates a lot of waste stream. And one of the waste stream is called these tailings, or sugar beet tailings. It's basically the roots and other stuff when they clean the beets. So that's what the waste is. So we designed a system for the American Crystal Sugar Company, which processes the sugar beets, to take these tailings and produce biogas. And the biogas would then be used in the sugar processing facility. So the project was to design a demonstration system which will handle about 2 to 3 tons per day. So that is to demonstrate the technology. And what they're doing now is they are taking the technology and trying to scale it up. They're building a 60 tons per day facility to deal with the tailings. So this is an example of all the different feedstock, the waste streams that we looked from the sugar beet plant. So we looked at the tailings. We also looked at the spent pulp after the sugar has been extracted. And we also looked at the raffinate. So it's a combination of pulp, tailings, and raffinate which is fed into the system. And basically, by converting all this to methane, they can displace about 60 to 70% of the current fossil fuel or natural gas usage in the plant by biogas that's generated on site. So that is a tremendous savings for them in terms of fuel costs. And since we ran this particular plant for about a year or two, and it's run successfully, and that's the reason they're going to a 60-ton per day facility now. So that's kind of overview of some of the work that we've done for the different biomass feedstocks to produce biomass. Any questions? So that's the system. So that's kind of the digesters that we use. This is for the sugar beet plant. So these are the 2 digesters that we use. These are 10,000 gallon tanks. This was before we insulated them. And you can see the heating system here. And those are the gas collection system on top of the digester.
It's continuous filling or it is a batch filling system?
It's a continuous system.
Yeah.
So basically we feed, that's a feeding pump. So essentially the biomass is brought into this bin here, and this is a trash pump which takes it up. We are trying to use an existing facility already, the sugar plant, to do this process. So we had to take it up like 5 floors, you can see that. And the digesters were 5 floors up. So yeah, it's fed every day.
Dirty material like sand, is left over?
About 90% of the material is degraded to biogas, so we still have about 10% of the residue which you have to work with. And that is like, sorry.
Yeah, well, that's leaving then.
That's leaving, yeah. Yeah. And we bring it down and then dispose it.
Yeah.
Did you do some life cycle analysis or in comparison in your proposal for use of biogas for some sugar beet residues and to use sugar beet residues as pellets to prepare pellets?
What they use is this stuff is usually set as cattle food. Mm-hmm. So, but they don't have a market for that. So this stuff is basically readily fermentable, and they don't have any farms nearby where they can ship that. And in fact, the cost of disposing these tailings is about cost of about $1 million or so a year. They have a market for that. They usually mix this raffinate with that, the cattle food, but really there's no market for the raffinate as well. So these two, there's no market currently. So converting to biogas makes economic sense to them.
Your proposal is to divide residue in two flows, or even.
It doesn't matter. We can mix all the three. It doesn't matter because we tried different trials. Sometimes we have all three going in. Sometimes just the tailings. It doesn't matter. The digester handles the different components. So it really does not affect the process.
First picture, we saw a container for 50 tons of biomass. Is it producing heat energy also?
Currently they're producing heat. They take the biogas through I think like an internal combustion engine, and they make electricity, and the waste heat is used for heat. Yeah.
Does it work in aerobic processes?
These are all anaerobic processes. There is no oxygen in it, it's all anaerobic. That's why you get methane from the process.
And are you using after that you get the methane approximately 50-60% and then some improvement, or you are using this biogas?
In the sugar plant, they're using it directly. All they do is they remove some water, dry the gas, and they remove hydrogen sulfide. That's about it. There is no upgrading. They don't upgrade the biogas to 100% methane because it's used on site. But there are systems which you can convert the biogas to 100% methane. There is a commercial process that are there.